Midas NFX Simulation Lecture 8 CFD Computational Fluid Dynamics Simulation. First of all, we will open a case and give it a name and import the geometry. And I'll make the z-axis at the right. Okay, we have finished with the first step, and we'll save the file on desktop. For second step, I'll load the material. There's material specifically for CFD modules. So if you use solid in CFD, I suggest that you still use this instead of this. So these are the materials designed for CFD modules. I'll choose fresh water 25 degrees C to be the fluid material. And I'll connect the material with the geometry through 3D. And make sure that you choose CFD interface. Use this tab to connect the geometry with fresh water. So we have finished with the second step, loading the material and connecting the material with the geometry. For step 3, in solid mechanics we simply choose the object and click OK. But in fluid dynamics, make sure that you merge the nodes. So this is very important step for CFD analysis. And then we choose the geometry and the mesh. So we're finished with the step 3. For step 4, the inlet property, we'll choose this surface as inlet, and the mass flow rate of 10 grams per second. So the water flow in at 10 grams per second. For outlets, here, I'll choose this surface as the outlet, and the 0 means 1 atmosphere pressure, so I'll leave it as default. So I have entered the inlet and outlet, and then this is inlet and this is outlet, and then I'll define the walls, and I'll select all the surfaces except for the inlet and outlet surfaces, and they are all walls. And there's a little bit of question about these fillet surfaces. I'll talk about that later. You can see from the figure that the fillet display in different colors. Therefore, I'm not very comfortable with the color, so I'll do the defining walls again for the fillet surfaces to make sure that all the surfaces are defined. So these walls, the 8 objects are chosen, and I'll make sure that these are walls. Because the color is different, so I'll do it again to make sure that it is defined. So I have defined the inlet property to be 10 grams per second, outlet to be 1 atmosphere pressure, and the other surfaces are all walls. In solid mechanics, it is all we need to do, right? But in fluid dynamics, you still have to define what you want to know or what you want to measure as the output. And in solid mechanics, all the result that you are required is simply displacement, stress, and strain, and at most safety factor. But in CFD, you get maybe 100 different results, and each have maybe 200 iterations. So there are tens of thousands of files. So you need to tell the computer, tell the software what you want to know as the result, especially where you want to measure what the value you are interested in. So for the result, I will choose this point at the outlet to measure the velocity at the outlet. And I also would like to know the entrance pressure and the pressure drop along the tube. So these are the results. Actually, for example, in SolidWorks flow simulation, it is called goals, and in ANSYS Fluent, it is called monitors. So we need to tell the computer or the software what we are interested in, or we want to measure something, and at this point or this quantity, the computer or the software will calculate the iterations until the error reaches a predetermined value. So this is the step that we need to do in CFD, where in solid mechanics we do not have. So again, I'll review the first 4 steps. The step 1 will be opening a case and import the geometry. Step 2, load the material as CFD fresh water and connect the material with the geometry using CFD tab. And then choose 3D meshing and make sure that we select the node merging of the nodes option, and then click on the geometry and mesh. For step 4, we defined the inlet property to be 10 grams per second of flow, and outlet to be atmosphere pressure, and all the other surfaces are walls. And finally, we'll define what we are interested in knowing the result or what measurement we will have. And I defined for the exit or the outlet 2 node points for measuring the velocity, and then I defined the entrance pressure and the pressure drop along the outer surfaces. So now I will choose step 5, and in step 5 I will choose steady state CFD and edit. So I'll determine the content of the CFD simulation. And actually in steady state you don't have to change the default, because for example in transient flow you need to define the time of calculation, the time steps, and also the initial conditions of maybe the pressure or the temperature or the velocity, the initial condition. But in steady state you don't have to enter the initial conditions, and you don't have to enter the time requirement to calculate. So you simply click on OK and start calculating. And in CFD, especially in Midas NFX, there's a very powerful tool that you can open the result before it is finished with calculation. So I've choose the result file during the solution phase. So this is the result, and I'll look at the outcome, for example the total velocity, and I can see the velocity or the pressure drop. I can see the pressure drop during calculation. It is still calculating the iterations, right? You can see from here that the iteration continues, but at the same time I can load the result file, open the result file, and look at the result during calculation. So this is a very powerful way of looking at the result. So in Midas NFX, I like this very much. So we can see that the velocity change and pressure drop during the calculation. And now we are waiting for the calculation to finish. So it seems that the calculation finished. So after the calculation is terminated, we can open the result, right? So this is the result, and we choose the final step, and this is the pressure drop. So we can actually see the pressure drop along the pipe. So this is the water, and you can see that the pressure is initially very high and it drops along the way. And this is the velocity changes. And we can also look at the inside of the velocity distribution by clipping the surface. For example, we clip along the z-axis or x-axis. So if we click on the x-axis at the point of 0 and add, so we get this clipping surface, and we can see that the velocity at 10 grams per second, right, the mass flow rate. So when it comes to the broader section, the velocity drops, and then it comes back to a narrow section, the velocity picks up. So this is the velocity changes in the process. So you can deselect. You do not show the clip plane. You don't have to delete the clip plane, because when you want to use it again, you don't have to define it again. You simply click on. So this is how we see the result. And also, if you want to see some result, for example, the pressure, you can extract the pressure or velocity here. For example, I'll extract the velocity, total velocity, here at the center of the outlet. And I chose these node points and extract a table. And at the table, I can mark all the result. And there are 101 steps for the 1000 iterations. And I'll make it graph. And this is the graph. The x-axis would be the step, and the y-axis would be the total velocity of the node point 280. And you can see that actually for the velocity reaches steady state at the early age. So you don't have to really calculate 1000 iterations. Maybe 50 or 100 is quite sufficient in this case, because it is a very simple pipe. So this is lecture 8 of Midas NFX. You can see that the fluid dynamics CFD module have also 6-step structure. So in the next problem, we will add temperature it. For example, we will have hot water coming from the left, cold water coming from the right, and warm water coming out at the center. So this will be the next lecture. So see you at the next lecture.